So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. So today we're talking about virtual power plants, or VPPs. Now, I'm a big fan of VPPs that provide substantial benefits to homeowners, that save homeowners money. It's free cash for the battery in which they invested. I'm not a fan of VPPs that provide asymmetrical benefits to utilities at the expense of homeowners. So there's some VPPs out there where homeowners may not really make any money at all, and the other entities, finance companies, utilities, aggregators, they make a lot. So let's dive into VPPs and see if they make sense for you based on all these details and considerations. Now, here's why we need VPPs. There's a shortage of power on our electric grid. During peak demand times, which used to be from 10 to 2, but right now are usually between like 4 and 9 p.m. So usually during these peak demand times, especially on hot days when there's a lot of air conditioning cranking along, and especially now that we've got a lot of AI data centers being built or considered to be built throughout the country, the shortages are getting a lot worse. Now, utilities could build new power plants and transmission lines to meet these demands. And indeed, that's what they would love to do. That's their preferred reason. They love data centers because it's a huge, basically forever demand for more electricity. And that's what utilities sell. But it's very expensive to build these power plants and transmission lines. It takes 5 to 10 years. And the data center companies and the hyperscalers like Microsoft, Amazon, Meta, Apple, Google, they really want power fast. They want to build these data centers fast. They don't want to wait 5 or 10 years. And also they don't want to pay through the nose for that power. So there's a much better solution. And that much better solution is to use virtual power plants to provide the short and the medium, and even the long-term power that these data centers need. And I'll explain why that happens. Here's what virtual power plants are. They're basically huge networks of home batteries. And these home batteries can be networked together to meet peak electricity demands, as I mentioned, usually between 4 and 9 p.m., and often on really hot days. So these VPP demand events may happen a few times a year on really hot, sunny summer afternoons. They may happen dozens of times a year, depending on the situation on the local grid and also depending on how many batteries, how large the VPP networks are. By using existing batteries actually paid for by homeowners, by using these existing batteries, these VPP networks have the potential to avoid additional utility buildouts and avoid a lot of additional costs to ratepayers. And therefore, these VPPs have the potential to lower everyone's electric bills. So it makes a lot of sense if instead of building new transmission lines, new generation systems, because we need extra power, say between 7 and 8 p.m. or 7 and 9 p.m., let's tap into those home batteries, pay the homeowner a little bit of money for that battery, for their power, and when it's in aggregate, it's all the power you need. Many utilities offer payments to homeowners as part of the VPP programs. Homeowners have batteries, you can get easily enrolled, and homeowners, depending on the location, depending on the VPP, can get payments of over $1,000 per battery. There's another very popular program that I've seen. It's easy to sign up, very popular. The homeowners get a flat $275 a year. And these programs are kind of complicated as far as how the rules go. And then I also saw one situation where the homeowner was guaranteed to get a single $100 Visa gift card for 25 years of use of their batteries with up to 35 VPP incidents per year. Crazy. And then I've seen some programs where the VPP was basically required with no other compensation, zero. Basically, the utility and the manager of this VPP was basically just using the homeowner's battery without any compensation. So if you have a home battery, say from Tesla or Franklin or Enphase or Lunar, depending on your utility, your battery And any financing you have on your battery, you can make some extra money. $275 is pretty typical. Sometimes it's 500, and I said there's some that are 1,000. So there's kind of free money if you lend your battery to the utility when they use it. Now, it's not exactly free because you're going to have to replenish the energy on there, and there's some other issues. But when I kind of go through the numbers, it's actually pretty positive with the right kind of program. Here's an example of the first large-scale test of virtual power plants in California. This test was done on July 29, 2025. And this is some data from the program. Now, you can see from this curve, the batteries that were used in this demand-side grid support program, or DSGS, that's a very good program in California. They discharged huge number of batteries between 7 p.m. and 9 p.m. during the peak times on this July 29th, 2025, a year ago. And the average output of all these batteries was 535 megawatts. So between 7 and 9, there was an extra 535 megawatts showing up on the local distribution grid, reducing the need for the utility to provide all that power. That 535 megawatts, it's about the same size as a gas power plant. The Metcalf power plant in South San Jose is about that same size. So by borrowing the capacity of these batteries, it avoids utilities having to construct new power plants and new transmission lines. VPPs, from an economic standpoint, they're a no-brainer for increasing the capacity of our electric grid. And you see that gray area at the top of the graph? That's how much savings was generated to all ratepayers for these VPPs without any additional grid investment. So it makes a lot of sense if it's designed properly. But here's a dirty little secret. Embedded in the utility business model, and fundamental to that business model, is that utilities get a guaranteed 10% profit on all of their assets. Those assets include power lines, power plants, substations, long-distance transmission lines. So utilities make more profits when they build more power plants, poles, wires, and install their own batteries. They lose incremental profits with VPPs since they don't own these assets. These assets are owned by homeowners. So if utilities don't own the batteries, if they're kind of forced to borrow these batteries, they don't make as much money. The utilities fundamentally, they want to build the power plants. They want to put in those substations. They want to build those transmission lines. So there's kind of an inherent conflict with this whole VPP concept. And candidly, that's why it's not taken off so fast. And kind of looking forward to the whole concept of vehicle to grid, kind of the same thing. The utilities would much rather build the power plants, the battery substations for vehicle to grid systems than to use the batteries in your car, even though it makes so much economic sense for society and for all the ratepayers. There's a lot of money sloshing around in the VPP business, and it's only going to grow. Utilities are the largest segment. They're the ones that have costs or offset costs for grid services and energy purchases. Next is aggregators. Now, aggregators are the companies that manage and optimize these VPPs, these distributed assets. And I call them consumer assets. They're distributed energy resources, but they're consumer owned. So it's very important to make that distinction. And I'll mention that in a second. So these aggregators do a good job. They're the ones that are writing the software, registering the batteries, telling them to turn on and off, listening to the utility signals, and kind of making that energy happen, exported from the batteries onto the grid. Companies like Voltus and Lunar Energy are two of the most popular there. There's also finance companies getting involved. Finance companies are the ones that are doing the third-party ownership structures. They're doing leases. They're doing PPAs. They provide the necessary capital and manage the financial risks. And pretty much almost all of the solar leases and PPA finance companies that I've seen recently have a built-in VPP. So the finance companies want to make some money off these VPPs. And at the bottom of the list are homeowners. They own the assets. They paid for them in cash. They borrowed the money from a credit union. They have a long-term lease for the battery. They own them. And they receive some incentives for their participation. And that's why I think it's really important to kind of look at all the cash that slops around. So let's see how much the actual owners of those batteries get. And I think you might be surprised when we dig into it. When utilities design and manage VPP programs, it's like the fox watching the henhouse. Utilities want to manage those programs with an eye towards increasing their profits, or at least minimize their lost profits. The lost profits are they would have made more money if they had their own utility substation batteries, but if they're forced to put in a VPP, they want to operate them so that they make the most money or lose the least. And it kind of goes without mentioning that the utilities really don't want to reduce your electric bills. They want to increase them. That's how they make more money. So I'm in favor of VPPs that are not controlled by the utilities and that are really designed to maximize homeowner benefits. Now, let's talk about those homeowner benefits. The bottom line, the question for people who have a battery at home and aren't yet enrolled in a VPP is, can I make money with a home VPP? Can I put my battery to use, lend it to the utility and the VPP aggregator at some point, and then get, $200-$300 or maybe $500 or $600 per year, maybe $1,000? The answer is you can't generalize. It's really hard to tell whether a VPP program is good or not. The VPP program payments sound like found money, but the actual terms and conditions of these programs are almost impossible to understand. And moreover, the actual economics are obscured and hidden. The utilities won't tell you how much more money they're making. The aggregators and the finance companies aren't going to tell you. All you really know as a consumer is how much money will I get when I turn my battery over to a VPP. Now, there are dozens of VPP programs active in the US right now. Let's take a look at two of them, which are very popular in California. There's the Demand Side Grid Support Program, or DSGS program in California, and there's the Emergency Load Reduction Program, or ELRP in California. They're both trying to do the same thing, which is find a way to add extra power to the grid, but there's big differences, and kind of step through that right now. So the administrator of the DSGS program is the California Energy Commission. That's a state agency. They're objective. They're trying to save money for everybody. The administrator of the ELRP program is PG&E and the other local utilities, like Edison and San Diego Gas and Electric. So those are the largest utilities, and they're investor-owned. They're trying to show as big a profit as possible. They're not going to have the most lucrative VPP programs in general. Let's look at the payout metrics. How is the money calculated for homeowners based on their use of their battery in the VPP? Now, the DSGS program is based on the total capacity of the battery or batteries that are committed to support the grid, not just exports, all the battery capacity. So in reality, it's more focused on supporting the grid fairly. And here's the interesting thing. The funding for the DSGS program comes from the state budget appropriations managed by the California Energy Commission. Basically, it's non-utility money. And according to what I found on Google, these DSGS programs have been paying out between $300 and $500 per year per battery. And we had enrolled a lot of our systems here at Cinema Energy Systems in the DSGS program. Customers were really happy. On the other hand, the ELRP program has a different calculation metric. They have a metric that you get compensated by the actual amount of energy exported to the grid during grid emergency events. So that may be, a half a dozen or a few emergencies during the hot summertime, 4 to 9 p.m., when there's basically a shortage of power in the grid. In the ELRP program, it calculates how much power and energy you send back. Now, keep in mind, these programs are more focused on extra power during emergencies, i.e. a grid failure or potential grid failure. So sometimes it's because the utilities hadn't upgraded equipment. They see that something's going to fail. Let's deploy extra batteries so that we can kind of solve a problem that probably should have been resolved with better maintenance. But that's besides the point. This ELRP program is managed and financed by the utilities themselves, and the money that they're using for it comes from customer funds and cost savings. Now, according to AI, these ELRP programs provide between $200 and $600 per year per battery. So fundamentally, both DSGS and ELRP, they provide about the same money. It's calculated in a different way. The money comes from different pots, but they're both pretty good. You also have to keep in mind the hidden VPP costs. Payments may be taxable depending on how that payment's done. And you would have to pay income tax on it if it's something that basically you're selling battery capacity utility. I have no idea how that would work, but keep that in mind. It's possible. You're going to get more cycling and wear and tear on your battery. It's not going to wear and tear instantly, but these batteries have a limited number of cycles that they can go through their lifetime. And just like a battery in your car or any battery, like the battery in your phone, the older it gets, the more you use it, the less the battery lasts, the less storage capacity it has. Another disadvantage is that these events are going to happen during peak time which means that if your house needs power during the peak time, you're going to have to repurchase that power later on in that peak time, or maybe repurchase that power at a partial or off-peak rate. So it's kind of not free power. You're going to have to replace it. Another disadvantage is you may not have as much backup power if there's a blackout. We have most of our customer batteries controlled where there's a minimum of 30% battery level. Manufacturers usually start at 20. I'd like to be a little bit more conservative for our customers. If you're using up that other 70% of your power, or even 50%, if there's a blackout, your battery's not going to last as long. Now, another cost or dilemma, the payment metrics, as I mentioned, they're very difficult to understand. I think the only thing that's more difficult to understand is your utility bill, but don't get me started. And then the other thing to keep in mind is that the program details and the payments are likely to change in the future. These VPP programs kind of don't go for 10 years. They typically go for 2 or 3 years, and they're going to be updated. And who knows what's going to happen in the future. Maybe they'll be more lucrative. Maybe they'll be less. Who knows? So kind of wrapping things up, all about VPPs, my opinion. There are some very admirably altruistic people that want to support the electric grid, although probably they're a minority since the electric rates keep going up. So most people aren't really disposed towards helping their utility altruistically. They're going to want to get paid for it. And some people want to get paid a lot, in which case they basically don't want to give control of their battery to someone else, especially an entity like the utility that isn't always on their side. The two California VPPs that I talked about, DSGS and ELRP, both pay about the same, but with very different metrics. Programs in other states are also going to be very, very different. Some programs provide a very heavily discounted battery to you. So they may say, instead of $15,000 for a battery, we're going to sell you a battery for $45 a year for 5 years. And you can get a battery really, really cheap. But then when you look at the benefits of this battery, they may not be connected to solar. It may be a battery only. So you're going to have to charge that battery up during off-peak times. And it may not allow you to cost shift your energy use, which is the main reason why people in California are buying these batteries now, so that they can charge their batteries during the day when they don't get a big reimbursement. There's no net metering. It's basically just for pennies. So their battery is fully charged by 3 or 4 in the afternoon. And then instead of paying the super high rates of 50, 55 cents, it used to be up to 60, between 4 and 9, they run their house off the battery. That's what I do. That's what most of our customers do. That's how you save the most money. So some of these programs don't really allow you to time shift energy use and save money on your battery. Well, in that case, if you get a really, really cheap battery, say for $5,000, it may still make sense. And then the last thing to remember when you're kind of evaluating these programs is, are you going to have blackout protection? Some of them may not include that. Some of them may discharge your battery down to 10%, in which case you're really not going to be able to run very much for very long at all. So try to understand the hidden costs of these programs. Hidden costs, as I mentioned, additional battery cycling, replacing exported energy, less available backup energy, and watch out for unfair programs. As I mentioned, the one that kind of freaks me out, I was just so upset with that company, I didn't even want to do business with them. They said that if you sign our solar lease, you will be required to enter into a 25-year VPP program, and we will be able to dispatch your batteries 35 times a year. That's for 25 years. And in exchange, you'll get a $100 Visa gift card one time. Boy, when I saw that, it's that the finance companies are really getting over their skis. So what I recommend, evaluate the programs that have the highest payments based on the structure and the VPP events. If you can, talk to other people that you know that have these programs to see if they really got checks or if there was some loophole that minimized the amount of money they got. I would say on average, in almost every single case, you're probably not going to lose money with high payout programs. You will make money, so it's probably a good idea. So if you're presented with a VPP, I'd suggest sign up if you're going to get $200 or $300 or $400 or more a year for the use of your battery, and then you can kind of test it out and see how it works out. All right, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can always go to our website at energyshow.biz and listen to the podcasts.
Thanks for tuning in to this week's Energy Show.